We also compress them. So this bale, if I stand on this bale, can you see it sort of squashes down a bit? It's got a bit of compression in it. And when you put weight on it, then it does make it compress a little bit more, and that's a good thing. It's that compression that we create that stabilises the straw. For a load-bearing building without a framework, that stabilisation happens because of the weight of the floors and the roof on top. With an infill building, if we've got a framework and we're just putting the straw between, we stabilise the straw so that we can plaster it so it's not moving about. But it doesn't need to be under the same compression as it is if it's for a load-bearing building. But whether it's infill, load-bearing or hybrid, we still compress the straw. So with our best bales, the ones that we get from the contractors, we generally can't compress more than a maximum of 1 centimetre per bale. So if a wall is generally 7 bales high, that means that we get about that much compression in the wall. For designers, that's what you've got to understand, and you've got to allow that into your designs. So when we design, that's why we say that the bale comes out of the machine at 365 millimetres high, but in our drawings we show it as 355 because we're allowing for that. What we're showing in our designs is a compressed bale, so you need to understand that. You've also got to understand, how do we physically do that? Especially if you're using a framework, you can't just design a frame to take all the compressed bales, because physically, how do you get them in there if the frame's here and when your bales are not compressed, they're here? How do you compress the bales and get them in underneath? So that's a practical, technical question that you need to really understand if you're designing, and you have to build that in. And we compress the bales generally in 2 different ways. One is that we put ratchet straps over the top of everything, just the ordinary lorry straps that you get, that you see on trucks, and we compress the straw that way over the wall plate. Or the other way is that we have a physical barrier at the top and we compress everything down using hydraulic jacks. So that's easier in terms of physical effort, and just those little hydraulic jacks that you pump up and down. And we prefer that method if we can do it, and that works really well on load-bearing buildings when you build the roof first. So people in the past used to build load-bearing just bit by bit, and the roof would be the last thing to be constructed. Nowadays, with our modern building methods, we build the roof first, then we put the straw in place, and then we drop the roof. So we're not talking about dropping it from a height, it's only dropping by about 50 millimetres, and we drop the roof down. But that then means that we've got the roof in place, we've got the cheapest construction method with load bearing, no frame, and we can just bring the roof down when we're ready, and then we compress the whole thing. So we pre-compress everything, we force the compression down, and then we're ready to go with everything else that we want to do. So let's think about, how can we make our walls airtight and very thermally efficient? So in the old days, the bales might just have been put together as they are, like this. And if you look at the end of this bale, it's not very flat, is it? So if I put this bale against another bale that's not very flat, what happens is that the high points hit each other, and I'm going to be ending up with some air gaps, which are too big to be called insulation. They're actually called drafts. So we have to reduce that, and this is one of the first things you do with your bales on the building site, is you take the bale, and we call it dressing, of the bale. So you take the bale, stand it up like that so you can work on it easily, and you look at it, and each bale you treat as an individual, because what I have to do to this bale will be different to what I might have to do to that bale that you're sitting on there, because they'll look different at the top. So I'm looking for where the high points and the low points are, and I don't want to take straw out from underneath the string, because that will reduce what density we have got here. But what I do want to do is move the straw around under the string to make this flat. So I'll first of all move a bit of straw across here. So it shouldn't be as easy as this. So this is another indication that these are not good construction bales. So I'll just physically shift this straw from one side to another to try and make it flat in the middle and a bit more square on the corners. So can you see now, you can start to see the strings showing here where you couldn't see them before. Yep. So then I'll just batter those corners just to encourage them to be more square. But at the moment, I've made it look worse than it was before. Yeah? So it looks even worse now in terms of coming flat against another bale. So then the next thing I do is I physically take out some of the straw. Again, trying not to take it out from under the strings. I'll take it out from the middle where it's high. And then that looks a lot better, don't you think? Yeah? So on a building site, this doesn't take very long at all, and we can do it with an alligator saw as well. I don't want to use that here, but you can trim the top off with an electric saw. So if I stand that up now, that's pretty good, isn't it, as a flat surface? So if I do that to both ends of all my bales, and then I put them together in the wall, you can see that I've improved the thermal efficiency dramatically. And I think that some of the early buildings made 20 years ago, if we put a thermal imaging camera on them, we'd probably see some of the joints showing up as heat loss areas. We don't do that anymore, but some of the self-build, volunteer-built buildings are a bit like that. So you need to be careful if you're doing self-build and if you're using volunteers about the quality of the build. It's really important to get that right. Okay.